Hello everyone, and welcome to this interesting session about Apriori algorithm. Now many of us have visited malls and supermarkets such as SM or MEDALLA for our household needs. Well, let's say that we are planning to buy a new laptop. What we would typically do is search for the model by visiting the mobile section of the store, and then select the product and head towards the billing counter. But now, the goal of the organization is to increase the revenue. Can this be done by just pitching one product at a time to the customer? Now the answer to it is clearly no. Hence organization began mining data relating to frequently bought items. So market basket analysis is one of the key techniques used by large retailers to uncover associations between items. Now examples could be the customers who purchase laptop. 60% likelihood that they will also purchase mouse and bag. Customers who purchase laptops are more likely to purchase laptop bags as well. They try to find out associations between different items and products that can be sold together, which gives assisting in the right product placement. Typically, it figures out what products are being bought together, and organizations can place products in a similar manner. For example, people who buy iPhone also tend to buy AirPods, right? And the marketing team at region stores should target customers who buy iPhone and AirPods, providing an offer to them so that they buy a third item, like cases. So if a customer buys the phone and buds and sees a discount offer on cases, he will be encouraged to spend more and buy a case. And this is what market basket analysis is all about. This is what we are going to talk about in this session, which is association rule mining and the imperial court. Association rule can be thought of as an if-then relationship. Just to elaborate on that, we have come up with a rule. Suppose if an item A is being bought by the customer, then the chances of item B being picked by the customer to under the same transaction ID is found out. You need to understand here that it's not a casuality. Rather, it's a co-occurrence pattern that comes to the force. Now direct two elements to this rule. First is the if, and second is the then. Now if is also known as antecedent. This is an item or a group of items that are typically found in the item set, and the later one is called the consequent. This comes along as an item with an antecedent group, or the group of antecedents approaches. Now if you look at the image here or B, it means that if a person buys an item A, then he will also buy an item B, or he will most probably buy an item B. The simple example that I gave you about the phone and the buds is just a small example. But what if you have thousands and thousands of items? With that data, if you go to any professional data scientist, you can just imagine how much of profit you can make if the data scientist provides you with the right examples and the right placement of the items, which you can do, and you can get a lot of insights. That is why associate rule mining is a very good algorithm, which helps the business make profit.
Now let's discuss about Apriori. It uses the frequent item sets to generate the association rule. And it is based on the concept that a subset of a frequent item set must also be a frequent item set itself. Now this raises the question, what exactly is a frequent item set? So a frequent item set is an item set whose support value is greater than the threshold value. Now just now we discussed that the marketing team, according to the sales, have a minimum threshold value for the confidence as well as the support. So frequent item set is that item set whose support value is greater than the threshold value already specified. For example, if A and B is a frequent item set, then A and B should also be frequent item sets individually. Now let's consider the following transaction to make the things a little easier. So suppose we have transactions 1, 2, 3, 4, 5, and these items are there. So T1 has 1, 3, and 4. T2 has 2, 3, and 5. T3 has 1, 2, 3, 5. T4, 2, 5, and T5, 1, 3, and 5. Now the first step is to build a list of item sets of size 1 by using this transactional data. And one thing to note here is that the minimum support count which is given here is 2. Let's suppose it's 2. So the first step is to create item sets of size 1 and calculate their support values. So as you can see here, we have the table C1 in which we have the item sets 1, 2, 3, 4, 5 and the support values. If you remember the formula of support, it was frequency divided by the total number of occurrence. So as you can see here, for the item set 1, the support is 3. As you can see here, that item set 1 appears in T1, T3 and T5. So as you can see, its frequency is 1, 2, and 3. Now, as you can see here, the item set 4 has a support of 1 as it occurs only once in transaction 1. but the minimum support value is 2. That's why it's going to be eliminated. So we have the final table, which is the table F1, in which we have the item sets 1, 2, 3, and 5, and we have the support values 3, 3, 4, and 4. Now the next step is to create item sets of size 2 and calculate their support values. Now all the combination of the item sets in the F1, which is the final table in which you discarded the 4, are going to be used for this iteration. So we get the table C2. So as you can see here, we have 1, 2, 1, 3, 1, 5, 2, 3, 2, 5, and 3, 5. Now if you calculate this support here again, we can see that the item set 1, 2 has a support of 1, which is again less than the specified threshold. So we're going to discard that. So if we have a look at the table F2, we have 1, 3, 1, 5, 2, 3, 2, 5, and 3, 5. Again, we're going to move forward and create the item set of size 3 and calculate their support values. Now all the combinations are going to be used from the item set F2 for this particular iterations. Now before calculating support values, let's perform pruning on the dataset. Now what is pruning? Now after the combinations are being made, we divide C3 item sets to check if there is another subset whose support is less than the minimum support value. That is what frequent item set means. So if you have a look here, the item sets we have is 1, 2, 3, 1, 2, 1, 3, 2, 3 for the first one. Because as you can see here, if we have a look at the subsets of 1, 2, 3, we have 1, 2 as well. So we are going to discard this whole item set. Same goes for the second one. We have 1, 2, 5. We have 1, 2 in that, which was discarded in the previous set or the previous step. That's why we're going to discard that also, which leaves us with only two factors, which is 1, 3, 5 item set and the 2, 3, 5. And the support for this is 2 and 2 as well. Now, if we create the table C4 using 4 elements, we're going to have only one item set, which is 1, 2, 3, and 5. And if we have a look at the table here, the transaction table, 1, 2, 3, and 5 appears only 1. So the support is 1. And since C4, the support of the whole table C4 is less than 2, so we're going to stop here and return to the previous item set, that is C3. So the frequent item sets are 1, 3, 5 and 2, 3, 5. Now let's assume our minimum confidence value is 60%. For that, we're going to generate all the non-empty subsets for each frequent item sets. Now for I equals 1, 3, 5, which is the item set, we get the subset 1, 3, 1, 5, 3, 5, 1, 3, and 5. Similarly for 2, 3, 5, we get 2, 3, 2, 5, 3, 5, 2, 3, and 5. Now this rule states that for every subset S of I, the output of the rule gives something like S gives I to S. That implies S recommends I of S. And this is only possible if the support of I divided by the support of S is greater than or equal to the minimum confidence value. Now applying these rules to the item set of F3, we get rule 1, which is 1, 3 gives 1, 3, 5 and 1, 3. It means 1 and 3 gives 5. So the confidence is equal to the support of 1, 3, 5 divided by the support of 1, 3. That equals 2 by 3, which is 66% and which is greater than the 60%. So the rule 1 is selected. Now if we come to rule 2, which is 1, 5, it gives 1, 3, 5 and 1, 5. It means if we have 1 and 5, it implies we're also going to have 3. Now if we calculate the confidence of this one, we're going to have support 1, 3, 5 divided by support 1, 5, which gives us 100%, which means rule 2 is selected as well. But again, if we have a look at rule 5 and rule 6 over here, similarly, if we select 3 gives 1, 3, 5 and 3, it means if we have 3, we also get 1 and 5. So the confidence for this comes at 50%, which is less than the given 60% target. So we're going to reject this rule. And same goes for the rule number 6. Now, one thing to keep in mind here is that although the rule 1 and rule 5 look a lot similar, they are not. So it really depends what's on the left-hand side of the arrow and what's on the right-hand side of the arrow. It's the if-then possibility.